Well, welcome everybody, and to our summer edition of our open house hardware day for the Computer Museum. And we're very pleased today to have Lanny Cox, who is a local computer enthusiast, works in cybersecurity at Wilfrid Laurier, and is also a member of the local computer heritage group who are into vintage computers. And today Lanny is going to show us what he's been doing with a Pi-based PiDP-11 emulator. I think he also has a PiDP-8 emulator. And that's why we have a bunch of PiDP-11 paraphernalia out here today, and including our watt cap. So we're very glad to have him here and to give us a little talk today. Go ahead, Lanny.
Thank you. Let's move it. All right, afternoon everyone. I'm going to take you on a bit of a guided tour of some big clunky 1960s and 70s mini computers that have a very significant place in computing history. I'm going to talk about the community that still exists around these computers and the people that still continue to use these computers in some form up to the present day. I'm also going to talk a little bit about some modern efforts to simulate these machines, both from a software standpoint as well as the physical look and feel, without using up the room's worth of space or having to take out a second mortgage to pay the electric bill, which you'll understand a bit more in the slides to come. And I'll demonstrate some of my own experiences with building and using some of these hardware recreations. So a little bit about myself before I begin. Lifelong computing enthusiast, born on the East Coast in Newfoundland. Would have first laid hands on a computer, I think, when I was 8 or 9, instantly hooked. Despite this, didn't really have any aspirations toward computer science or IT for a living. Got a music degree, did that for 5 or so years, got tired of it. Lo and behold, ended up in IT, public sector, private sector, manufacturing. About 6 years ago, found my way to Waterloo. Last few years, I've been working on the cybersecurity team at Laurier. Hold your booze and pisses until the presentation's over. If you do want to read more about some of this stuff, I have a website. The address is on the screen. Just give it a visit. Drop me a line if you want. No one else. So as I mentioned, I'm largely going to be focusing on a line of mini computers made by the Digital Equipment Corporation, or DEC, through roughly the mid to late 1960s up to the early 90s. This presentation isn't really about DEC, the company, but it is important to know a little. So we're talking a company started in the mid-1900s by a couple of MIT students, major player in the industry, competing with giants like IBM, GE, and so on. Had a number of different product lines. Some of you may have heard of the VAX line of mini computers. That was in the 80s, or the DEC Alpha line in the 90s. The main topic of discussion will be the PiDP series, and those came beforehand. PiDP stands for either programmed data processor or programmable data processor, depending on who you ask. Those computers were in production from 57 up to 1990 in particular. So the first PiDP model was the PiDP-1, which is the computer in that picture. That was released in 1960. Early on, these were very expensive computers. They didn't sell overly well in volume, but they sold for a lot. There were about 50 of these made. So that's still significant when you consider those were very costly machines. The PiDP-1 cost over $1 million US, adjusting for inflation. So that was moderately successful enough to basically get them established. Then came the PiDP-4, PiDP-7, doesn't necessarily go in order. That was a bit more widely manufactured. Those probably sold about twice that. So the first major model I'll talk about is the PiDP-8. I don't want to spend too much time talking about that computer, but I also can't understand it, understate its importance in DEC's history. The fun fact about this system, this was intended as a stopgap machine between a couple of other models. The original business plan called for about 1,000 units to be made. In the end, they sold over 10 times that, so highly successful by the standards of the time. One of the big reasons that the PiDP-8 sold so well is that it was also a much lower cost computer than the older machines. It was the first to be sold for under $20,000 at the time, and it was done on a physically smaller scale, and that allowed it to be dubbed as one of the first mini computers. And at this point, DEC essentially defines a whole sort of subsection of computers or market segment to kind of sell these machines to. And it immediately becomes a leader in that kind of class of computing. So from here, we take another big leap. The PiDP 11 was introduced in 1970. It's kind of important to know the context in which the computer is being introduced. Even though mini computing was starting to make computers a little more accessible in academia or mid-sized companies, a lot of important work was still being done on these huge mainframes from IBM or CDC. There weren't any microcomputers, we'll say, available at the time, so there was no real home computing happening or anything like that. You could make the argument that computers at the time also weren't quite as interactive in a way that a lot of modern personal computers are. So in those days, you'd come up with a program, you'd create a whole stack of punch cards that contained that program. You'd hand it off to a computer operator, which was a dedicated job for the time. It gets input into the computer, along with a bunch of other programs that's known as batch processing. And eventually you get another set of punch cards back that contain your output from your program. So if you made an error in your program, you're going to have to recreate that program, you're going to have to send it along as another batch. It can be kind of tedious. That whole idea of sitting down at a terminal and having an extended conversation with the computer, so to speak, it wasn't really as prominent in the time. That's not really what people thought of, I guess. The first PiDP 11 also cost about 20 grand US at the time. That adjusts to about 160 US nowadays, so 220 Canadian, according to my math. With that, you got 4K of RAM, a CPU that ran at the equivalent of 1.25 megahertz, and a bus called the Unibus to interface with your hardware and peripherals. Bear in mind, this does sound limited, and even kind of was for the time from what I've kind of heard. But that line of computers also had a 20 or 30-year shelf life as well. So later on, it'd be more common to see a computer with something like 4 megabytes of RAM. It did come with a ASR 33 teletype console, which is in that image. That's going to be an important factor. Storage came in the form of early hard drives or tape drives. Paper tape was still a thing as well. It used assembly language that was created for the computer called Macro 11. Could address 16 bits, meaning up to 64K of memory at a time. Again, this was expanded later on. So in terms of what people could do with this computer, a lot of the same things you do with a microcomputer nowadays, we're starting to get to that kind of same point where it serves functions in data processing. Some were used to control other hardware or any instrumentation, for instance, running robots in factories, automation. Sometimes they just served as really complex and capable calculators. Eventually, the military picked them up and they used them for missile defense, they used them for air traffic control, telecoms used them commonly, nuclear power plants used them commonly, and eventually DEC kind of moved on to more powerful and compact lines of computers like the VAC series. But at the same time, a lot of organizations that initially invested in PiDP 11s kept them in production for quite a while. So that series wasn't discontinued until 1990, so it did have quite the shelf life. So if you look at that picture, we've got a couple of interesting looking fellas. Their names are Ken Thompson, that's Dennis Ritchie sitting at the terminal. They're going to end up being responsible for some pretty important innovations in the years to come, and a lot of it has to do with this particular machine. So, lo and behold, from the PiDP series comes Unix and the C programming language, and those are both inventions that are still in use today. So for those unfamiliar with Unix, it's a time-sharing operating system originally developed by our friends Ken and Dennis in tandem with Bell Labs. The first version, from what I understand, was written in PiDP 11 assembly. 2,400 lines of code running on 12K of memory with a maximum file size of 64K. Put things in perspective, I don't think I could fit this presentation out there if you shrunk it down tenfold. It also included text editors like Ed. Let me tell you, if you don't like working with Vi, don't even go near it, trust me. It'll put things in context real well. And it also included tools to work with hard drives, your tape drives, your peripherals, and utilities. It also came with games, blackjack, chess, tic-tac-toe, so if you got tired of programming and assembly and the deck was spinning, you had something to calm down with. More importantly, it provided a time-shared environment that worked with keyboard and printer terminals like those ASR 33 teletypes and later on consoles with a keyboard and a screen. From there, you get advances in interactive computing, so less punch cards or no punch cards, a lot more two-way communication with the computer. From there, you get your office productivity tools. You start to see things like word processing or emerge, and you can kind of see where that leads eventually. From a historical perspective, you can also draw a squiggly line through evolution in operating systems. So Bell, AT&T Unix, that led to Berkeley Systems Distribution, BSD Unix. That led to Mac OS, which uses a version of the BSD kernel, or at least used to for language time. I wouldn't call this a direct evolution, but you also have a lineage you can see between Unix and Minix became something that was intended to be a teachable version of Unix. Then from there, you see Linux being created as a result of Minix. Then you see Android, which incorporates Linux, and you kind of see where this goes. The other big advance that I mentioned that comes from our friends Ken and Dennis is the C programming language. So prior to this, a lot of programming was being done either in assembly language, or we'll say, I guess, relatively low-level languages like Fortran, COBOL, that sort of thing. Those sort of range from, I'll say, not quite user-friendly to incredibly difficult to use for a novice. Assembly is something to learn from scratch. It's a great skill, but not user-friendly. C was developed for the purpose of developing Unix, and consequently, a lot of the functionality of C, it mapped nicely onto those emerging hardware capabilities of the PiDP-11. So by 1973, Unix had gone from something that was written in assembler to being compiled in C. So now you have this interactive operating system, you have a higher level programming language, so you don't need to know assembler anymore in order to develop for that line of computers. So you see more of these computers that sell to all segments of industry. More people start to work with computers that didn't necessarily hold that job title of computer operator. So when I said 10,000 PDP-8s were sold and that was considered a huge success, by contrast, DEC sold over 600,000 of these, so you can imagine. So despite all that, we have these, what you'd call unpersonal computers, more or less. Certainly not something that you're going to set up on a desk in your living room anytime soon. And those machines are obviously no longer in production. Slowly, throughout the 80s and 90s, you start to see different paradigms of computing emerge. So you do see microcomputers. Computers become more and more powerful, smaller, more cost-effective. A lot of major moves and shakes later, DEC itself was gone by 1998. And yet people are still interested, people still want to experience those mainframes and mini computers, that sort of thing, write software for them. And this is where simulators started to come in. So the major one I would talk about is SimH. That was created by a man named Bob Supnick, who was an engineer and vice president for, you guessed, DEC. And it's all more or less continual development over the years, and it basically simulates various hardware designs, both by DEC as well as a lot of other companies like IBM, Data General Computers, that sort of thing. Meaning that all the functionality of that hardware is replicated in software. Your operating system sits on top of that simulation of the hardware by the computer running SimH, and you interact with it in the same way that you would have interacted with the actual hardware many months ago. So now you have the ability to run PiDP-11 software on a modern laptop that runs Linux, for example. So you have the simulator, you can run all this classic software on it, play the PiDP-11 versions, work if you like, and we're having a grand old time, but something's still missing. If there's anything that old computer junkies love, it's blinking lights, flipping switches. So we say to ourselves, why can't we replicate that as well? So from here, there's a couple of intermediate steps before we get to our destination. One of them is the Raspberry Pi. Many of you may already be familiar with that. It's a very powerful, very inexpensive, and very small computer that runs a number of operating systems, including Linux, meaning SimH also runs on. Another big feature of this machine is a GPIO bus, which gives you this easy-to-use I/O interface to work with if you're a hardware developer. Let you connect those lights and switches, and you can already kind of see where we're going. And from here, there is one other big innovation on the software side that was called the Blink and Bone project. The best way you could describe that is like an API or an extension that enables you to wire up a physical front panel and have that front panel be recognized by a piece of software like SimH. So now we're getting somewhere. So all this software preservation work, you have SimH, you have the Raspberry Pi, you have Blink and Bone. Where does that get us? spoiler alert right there. So that's a PiDP. This is basically a Raspberry Pi running SimH and the original PiDP disk images and operating systems. It runs Blink and Bone with the front panel design, the functionality of the full-size PiDP, as you can see from some of those machines over there. And very unlike the original, it's less than a foot long. You can just see portable enough to fit in the backpack, so I brought it here. Obviously, you no longer have the original old CPU or the old memory that was used in the actual PiDP-11, but you do have the lights and the switches and the design aesthetics of that sort of machine. And it's available in kit form to build. If you have a soldering iron and a few hours worth of time on your hands, the sky's the limit. You can just order one, do it yourself. So similar to the computers that they imitate, there are a few different PiDP models as well. I own the PiDP 8 as well as the PiDP 11, which is the one I brought along with me today. PiDP 11 simulates a PiDP 1170 in particular. So for some perspective, this variant of the PiDP 11 has 4 megs of RAM. Uses a newer storage bus compared to some of the older ones as well, called the NAS bus. It's definitely one of the nicest PiDP 11 models, which is probably why they chose it for simulation. They run about $200 or $300 as a kit. They're available through a small company called Obsolescence Guaranteed, who've also done some simulations of, say, the Commodore Kim as well. There is an Apple One kit that I believe is in production, as well as one for the PiDP 10, which is an absolutely beautiful machine that I unfortunately haven't been able to find the time to build as of yet. That one actually runs a OS called the Incompatible Time Sharing System, which is in use at the MIT AI lab, I believe, in the early 70s, and it is unlike anything else I've seen. There are actual access that you can get online to these machines, and it's great. It's well worth checking out. So, in terms of building the kit, the PiDP 11 has been around since 2018. I was finally able to build one over the holiday break last year. I don't really have a ton of insights on building the machine. I'll say it was challenging without being overwhelming. I wouldn't call myself an expert in soldering or electronics in any respect. I would say I had most difficulty with soldering switches onto the machine. They're a little bulky and they can be kind of fun to align properly. You do get some tools that help you do that, but it can still be difficult. And also ensuring that all the I/O pins on the Raspberry Pi's header is soldered in properly. You can see from that photo on the bottom right that I had trouble with lighting up a section of LEDs. Those are all mapped for multiplex to 1 or 2 pins on the Pi. I hadn't soldered those in properly, so that was probably my most difficult troubleshooting battle. It comes with some software that helps you test as you build as well, which is also nice. It kind of points you towards the source of any issues. And it's also well supported. There's a busy support forum, so the hardware is well documented. You ask a question, you can get an answer pretty quickly on it. So overall, it probably took me about 6 hours of time between a couple of different sessions. I was up and running. I wish I would have gotten more pictures of this one. You can see a couple there. I went into a bit more detail with the PiDP 8. If you're interested in seeing that, it's on the website as well, a bunch more images. You can't really see it from the pictures, but another thing to note is that this PiDP 11 has got a lot of options for expansion. So theoretically, you can run this whole thing off of Wi-Fi and just have it connect to your home router, and you connect nothing but a USB cable for power and stick it on your bookshelf. And that's what I did with my PiDP 8. But for this model in particular, there are options to connect a HDMI monitor. You can connect a USB keyboard and mouse, which will get you out of the pinch if something's not working correctly and you can't communicate with the machine. There's also 4 cutouts for 4 DE9 serial ports. So you can interface an actual serial teletype to this thing or control it via a terminal emulator like PiDP if you have one of those USB to serial adapters. I actually added an Ethernet port to this machine just for the purposes of today's presentation, but like I said, it's just as easy just to put it on a bookshelf, control it remotely. And believe it or not, there is a way to use Unibus hardware on this machine as well, through something called the Unibone project. It's not something that I've tried at all. Who knows? If you're adventurous and you don't mind having a bunch of DAC hardware kicking around in your basement, the sky's the limit there. So in conclusion, just the takeaways from building something like this, I would say whether you're a computer science student or you have some with general interest, you owe it to yourself to dig into some of these older machines and those older paradigms of interacting with the computer, even if it's just If you want to play on some of those machines over there, touch screens are great, GUIs are great, but there are other ways to get the job done, and it's kind of interesting to dig into those. Coming from where I did, the same time period that I did, we're so spoiled nowadays for being where we are and being in the time period that we are, having access to pretty much any type of hardware or software. And you've got the real deal here. I mean, there's literally a PiDP 11 just sitting in this room. That's not common in 2024. I've been obsessed with these machines more or less my entire life, and I hadn't even seen one in person until 6 months ago. I just ducked my head around the office over there. Yeah, sure enough, mind blown. If you go across the hall, there's a whole library full of journals, manuals, you name it. That's the entire history of computing just sitting over there, so take advantage of that for sure. I would say also, this is great to help you dig into electronics and kits. If you like Legos, these are electronic Legos. It's frustrating, it's tedious, it's rewarding. And finally, I would also say that it can be overwhelming to build and use something like this, but there are other ways to get into it that don't involve spending $300 on a kit if you're worried that you won't like it. If you don't want to buy the kit, the OS image is available online. The software is not available online. Realistically, you don't need this front panel. You don't even really need the Raspberry Pi. You can kind of just spin up a VM and just download the PiDP image and kind of run it off of that and just try out some of the different OSs that come with it, some of the different software that comes with it. It's an unfamiliar experience, but if you're burned out on Windows 10, Mac OS is just something else to try to kind of get you out of that kind of monotony. The older you get, the more you do something, the harder it can be to be inspired, so this is how you maintain it. So that is it for our presentation. I'm going to try a demo here. Hopefully this will work well for me. So I'm going to see if I can duplicate these screens. So I'll give you an idea of what I've done here. There we are. Okay, so this laptop, this PiDP, they're connected via Ethernet. I just configured it on the same subnet, just kind of ad hoc network between the two. You SSH to the PiDP. The operating system images you'll see there, those are selectable using the front panel switches on the machine. So right now, all those switches, they're all zeros and octal, they're all down. So it's booting into something called idle. And all idle did is basically blink a few lights on the front and it gives you a boot menu. So from what you can see, there are options for images of a number of different OSs. RSX11 is a big one. Arista 7, RT11, DOS 11. That's Bell, AT&T, Unix 5, 6, 7, 211 BSD, which is what I'm going to show you here in a moment. There's System 5. There's also a couple of test programs, so that IDLE and Blinky as well. Blinky is one that just blinks all the LEDs and kind of sort of demo mode, I guess, and it's good to kind of test out your LEDs as well. So the way this works is you set in octal using the front panel switches on the machine which image you want to boot to, and you basically just reboot the PiDP. Usually you can just punch in on the selector switch. I've found the last couple of days this one's not working as well, and in the interest of kind of keeping things consistent, I'm just going to manually reboot the machine. So what I'm going to boot into is option 1000. It's called Nankervis. So there is a gentleman named Paul Nankervis who works with the it's TUHS, the Unix Heritage Society, and he maintains a set of images of different operating systems, different Unix systems. The ones that come with this machine by the developers, they're nice, but they're bare bones images. There's not a lot installed. They're neat from a historical perspective, but they're a little bit less usable. Whereas some of these Nankervis images have a lot more software already installed, a lot more configuration is already done. So I figure it would be more interesting to switch over to those machines. So what I'm going to do is set the front panel switches. So we're going to have option 1000. So we're going to count this way. I'm going to set 0, 0, 0, 1. So I'm hoping I'm not looking at that wrong because I'm upside down, but that should be 1, 0, 0, 0 in octal. And from there, I'm just going to reboot this machine, and it should reboot into a loader for the Nankervis images. So we just do a Control A and D in order to detach ourselves from the Pi. I'm going to do a sudo reboot, I need to enter my password. No, I don't. That's good. So we're going to give it a second or two just while it restarts. You'll see the LEDs will flash a little, so we'll give it 5 or 10 seconds. Once it gets rebooted, the way it works is an Anchor system already has a number of virtual disks that are attached with various operating systems. So we'll pick the one to boot into. There is a guide. It's not all displayed on screen. Most of the common ones that I mentioned earlier are all included. We'll try restarting the session now. We ain't there yet. May take a few more seconds. But we'll boot to a 211 BSD image once that's done. At that point, I might have to drop the mic as well. And I'll just be horrifically impatient while this boots. This might not actually. I'm gonna try this one. I swear this worked fine 10 times in a row when I tested the last week. First comes the worst, we'll just boot into one of the other ones, but I like to get this one running if I can. The slow black screen here might actually be the design. I guess I can always just paint the thing to the meantime. Ah, here it is. Cool. All right, so we booted into that this image that I mentioned. I know you guys have done this a few times. We're looking to boot disk RP1, which contains 211 BSD. So I'll do a boot. RP1. It'll take a second or two and then it'll boot. And that's BSD 2.11 booting. In a second, it's going to prompt me to log in. Okay, I'm going to log in as root. And there's no password because we're back in the 1970s. All right, so right now I have a BSD 2.11 image. Let me see if I can just drop this mic for a quick. Yeah, so you can just run your bog standard Linux commands. There's certain things that don't work immediately. The Unix environment's obviously changed a lot over the years. Like I noticed things like add user didn't work as intended. I know that the image that came with the PiDP itself didn't include vi. It's add only, like I had mentioned. One of the reasons going to this one instead. That being said, this is still an incredibly capable operating system. I know with both BSD 2.11 as well as I believe RSX 11, there's a full networking stack. So what you can do is basically connect an Ethernet cable outside of the realm of having the Pi itself networked. You can network this machine on a local network, and it has an email client. It's absolutely absurd. It's so great just to be able to, communicate with the machine from the 70s using your new computers nowadays. I could just show you a few examples, I guess. We'll do games and CD user games. Yes, there. So this comes with a bunch of different, there's a hacks there, Hangman's there, nothing like this. There are Unix quiz games, Ink is there. Yeah, everything you could ask for. I don't really think it's much of a point where you get too far into these. You can kind of imagine where things go from here. Just talking about some of the other capabilities of these machines as well. You can connect a vector console as well if you want to do vector graphics, which is very cool, so it's not just text only. Full networking capabilities, the ability of people to develop and share software for these machines is also great. Those forums that I had mentioned for the PiDP have a lot of people who are just developing software in 2024
they're creating their own disk images or their own tape images, and they're sharing them around with each other. It is very, very cool. I guess there's not too much else I can think of offhand. Let's see. There's a banner program. I don't think there is. Maybe there's not. There they are. And if you have a dot matrix printer, you can print the thank you message. That's pretty much all I've got. Anyone have any questions at all? Sure.
Larry, if NROF was one of them.
NROF?
Yes.
Not familiar with the program, sorry. What?
It's a text formatting.
I'm not sure if it's there or not. Sorry?
No, it's okay.
Don says.
I'm sorry, yeah, I'm not overly familiar with it. It may be.
T-ROF?
T-ROF, NROF,
Yeah, I don't know where you find
QN?
QN.
TBL?
Is there a fine QN?
Maybe. There is a fine. So it's
Find
fine.
T-ROF.
Q-ROF. Is that it?
T or
TROFF.
T as in Thomas.
Trop? Okay.
Two F's. There it is.
It looks to be there, yeah, it's in user bid.
Try NROF.
Yeah, they're both there.
There you go.
If you want to go back in time, opportunities there.
No.
Well, if you don't like latex.
Battle days, right? Yeah. Might cover a few people with that
What
one.
you're saying is we want a really crude scripting language.
Yeah, so there you have it. You want to shut down?
Slept for 6 hours.
And then there's always the dreaded Emacs.
Yeah, I think Emacs is included.
Oh,
No, it's not actually. No. With this, like I mentioned, with this particular one, Vi is there, but it wasn't with the base image, so I'm imagining that's something after the fact. Or it's after the same feeds.
XCD?
Is that? I don't think so.
Well, would the whole X Windows be on here?
I don't think so.
XCD, yes.
It might be here.
Or ED.
And I mean, like I mentioned, there's like so many other options as well in terms of, sex versus those machines. It's not limited to that one.
So you were saying about attaching a serial terminal.
Yep.
What was it is there physically a thing, a connector on
Yeah,
there?
I guess you can kind of see from the back there are
Oh.
cutouts for DB25 and DE9 ports.
Okay.
There are a couple of different ways to go about it. The Pi has, I think you can do it with a USB, the serial cable. You can use one of the USB connectors of the Pi and do it that way. There are also serial pins on the Pi itself. I think there's like a 2-pin computer or something like that. And yeah, it can be done that way as well. So lots of different connectivity options. I haven't really, honestly, had a lot of time to dig into it, but that's no shortage. With the 8 as well, like this one's a bit easier. Those are already there. The 8 still has a lot of the similar options, but it's like this one's a plastic molded chassis. The 8 is like a wood grain one, and it doesn't have any of the cutouts or anything like that. So it doesn't really lend itself as well to connecting those sorts of things unless you love working with the Dremel tool. But I think the software's there, just not the design aesthetics. I don't think they really had it in mind in that machine.
Any questions? No? All right. Well, I'd like to thank Lanny for coming to the side today. And I assume you'll stick around if people have any questions and things. It might be fun. So we have some things here just to point out. So we have a PiDP 11. We have not tried to turn it on. We've looked inside. It looked a little scary. We also have the Waterloo Portable Computing Facility, nicknamed the Watt Cow, computer on wheels. And the wheels are that cart there that was custom built. There's four big Rockstar boxes, as I call it. And and this was Don's group, it's your group there that did this stuff, and we used it for outreach into high school. So students would program on optical mark cards, run through the card reader, and the CPU, the disk, the printer, and the readers all there. We have not tried to turn that on. To do that properly, we should be opening it up, look and see, check the electronics, it'd be lovely to, as a project, to see if we can get it to work someday. But at least it's been pretty safely stored. So there's possibilities there, but you know, this stuff is very old, so it's interesting. Pardon?
Blow the dust out.
Blow the dust out, yeah. So that's definitely a very, you know, interesting restoration project we'd love to get to at some point. But getting people who really know what they're doing with checking electronics, I think would be. I would love it if people could fill out optical mark cards, write a little program, and run it through, and have it, you know, print on that printer or something. We have a number of machines here that you can play with that are available. There's a Selectric typewriter and several other machines there. And then because we were talking about portable computing, we have a lot of portable computers here as kind of that theme. And they're a little bit smaller and easier to move than that guy. So, and yeah, any other questions? We're going to be around, so you're welcome to stick around and ask. And thank you all for coming today.